Okay, the first thing we're going to do today is graphing quadratic functions. And if you remember, we used to put things in vertex form. And let me know if you can't see the screen, okay? For example, what if I want to graph something like this? Okay, and this is similar to one of the ones that we'll have. And first of all, this is in vertex form. Remember, we could do it in standard form as well. Standard form is more of last year's stuff. This is vertex form. And you're going to see on the worksheet that I want you to organize your work in a certain way. Okay, we're going to talk about all the different things about these parabolas. So the first thing I want to talk about is which direction does it open? And when I say opens, it either opens up or down. Does anyone remember? Raise your hand if you remember. You don't have to say it. Do you remember how to tell? Yeah? Okay, we see one person. Only one person remembers? Once again, give me it to a couple. Okay, there's a couple of them. So if this number is positive right here, it opens upwards. If this number is negative right here, it opens downwards. So I'm going to put opens up, up. Okay. Now, how do we do the vertex? Well, to do the vertex, I have to do a couple things here. Okay. Step one, what makes the parentheses equal to 0? Okay. Well, what number can I plug in for x to make this parentheses equal to 0? What number, take away 1, equals 0? The answer is 1. And it's always going to be the opposite of this number right here. Now, to get the y-coordinate, all I have to do is plug in 1. 1 minus 1 is 0. 0 squared is 0. Times 2 is 0. I'm left with a negative 9. That is my vertex. Let's look at our y-intercept. Okay. For the y-intercept, and you're going to show your work somewhere different. I'm going to have a chart here you're going to have to fill in for every one of these. So I'm just, because it doesn't fit on this page right here on the screen, I'm just going to do it right here. So to always find the y-intercept, we let x equals 0. So the y-coordinate is going to be 2 times 0 minus 1 squared minus 9. You can do order of operations or put that in your calculator, and you're going to get 2 times negative 1 squared, which is 2, minus 9, negative 7. This was your x-coordinate. This is your y-coordinate. Your y-intercept is 0, negative 7. Can you give me a thumbs up, thumbs down on whether or not you understood what I did here for the y-intercept? Once again, you plug in 0 for x in the formula, and then you put it in your calculator. Do you guys know how to put this in your calculator? I should bring it down here. Yeah? So if you put that in your calculator, the number that's going to come out with a 0 is negative 7. Okay? Now, if the y-intercept is, can you guys see this? Yeah. If the y-intercept is let x equal 0, then the x-intercept is let y equal 0. And solve. So I see my formula up above. You guys, maybe you can see it right there. Okay, so there's your formula, and I'm going to put 0 for y. 0 equals 2 times x minus 1 squared minus 9. Okay, let's solve for x. First step, you want to add 9 to both sides. I get 9 equals 2 times x minus 1 squared. Then divide by 2. I get x minus 1 squared equals 9 halves. At this point, I need to take the square root to get rid of the parentheses. And I'm going to get plus or minus square root of 9/2. I have to square root this side and do plus or minus. Remember, whenever you square root both sides, you have to do plus or minus. Okay? I take the 1 across, add 1 to both sides, and I get x equals 1 plus or minus square root of 9 over square root of 2. Let's start simplifying this fraction right here. The top is definitely 3, but the bottom has a radical in it. I have to rationalize the denominator. Multiply top and bottom by radical 2. That'll give us 1 plus or minus 3 radical 2 over 2. These are two x coordinates. The y equals 0 is the y coordinate. I have two x-intercepts. 1 plus 3 radical 2 over 2, 0. And 1 minus 3 radical 2 over 2, 0. These are my two x-intercepts. I don't know if I said y-intercepts a moment ago. So let's take a look at what we have so far. We have our graph. We have our y-intercept, 0, -7. I have my two x-intercepts. And if you notice, they're centered around 1. That means 1 is my axis of symmetry. I'm going to draw a line there. Now, you have to put this in the calculator to find out what it equals. So you can graph 1 plus radical 3 over 2, 3 radical 2 over 2, and 1 minus 3 radical 2 over 2. And I'm going to do that right now. I get 1 plus, and this is about the hardest one we'll have to do. So 3 times 2 to the power of 0.5 divided by 2. 1 plus 3 radical 2 over 2 is 3.12. If I change it to a minus, I get negative 1.12. So 1, 2, 3, and a little bit more, and I put a dot. Negative 1.12 is negative 1, and a little more, and I put my dot. My vertex, if you remember up above, was negative 1 comma negative, or sorry, 1 comma negative 9. Notice that the vertex always lies on the axis of symmetry, x equals 1. This was negative 7. Go 2 more down for negative 9, and there's my vertex. And now I have a general picture of where my parabola is going to go. I'm sorry, I'm not a good drawer. Maybe you can draw a smoother curve than I can. You just connect the dots that we have. We had our y-intercept, our vertex, and our x-intercepts. And now they want to know the domain and range. The domain is easy. It's all real numbers. This means everything from negative infinity to positive infinity. Every number can be plugged in for the function. But look, only certain numbers come out. And here's how we do the range. We have a minimum number. We have a lowest number. The lowest number is negative 9. So I put the negative 9 down here, and I put these brackets because it does include negative 9. I would put parentheses if it didn't include it. And it keeps going up to positive infinity. That is my range. Let me see if there's anything else I need to go over on this. Okay. We should actually state the minimum value. It has a minimum. Okay, I wish I could spell right now. Minimum value is -9. That's important when we do word problems. Okay, those are all of the moves that you have to make for doing each problem on this. The problem should be much easier than this. This is equivalent to the last problem on the worksheet. So when you actually do the worksheet, it should come out a little easier. I want you to try it out and we'll see how you're doing on this.